No se escucha.
Is it okay?
Yeah, it's okay now. Thanks.
Okay, great. So the context, no. I'll continue. So the Magic Town status, which was awarded to Sisal in the recent few years, has induced enormous tourism growth. And the region is still undecided on what to think of this status and how to cope with it effectively. Then there are also significant pressures from real estate development, with new regions being sold from the natural reserves, with new beachfront properties being developed along the Barrier Island. And then there's also obviously the impact of climate change, inducing tropical hurricanes such as Milton, and these will only become more frequent, as well as sea level rise, which will also threaten the resilience of the Barrier Island in the future. For the context, we specifically focused on a number of coastal transects, which have been measured by Gabriella and Gemma over the past 10 and 5 years, respectively. They have been measuring these transects on the west and the east side, walking with a GPS ADCP to measure the elevation profiles of the coastline and to identify the shoreline change over the years. And we've made great use of this data, and it's been enormously valuable for our research. And we'll get more into these later. Then the problem analysis. So as I said, there are numerous natural and anthropogenic perturbations, which are causing great changes to the coastline, for better or for worse. From our literature review, we have identified that there have been previous attempts to quantify the resilience of the region. The most famous index perhaps being the Coastal Resilience Index, defined by the US Army Corps of Engineers, and that has also been applied to the context of Sisal. Other methods have also been utilized using imagery from remote sensors. However, the assessment of resilience is only as powerful as its definition. And so what we've identified is that a lot of indices do not consider the variability of the system over time, nor do they consider historical trends, often focusing on a mean state of the system. Furthermore, as with many technical analyses, there is little consideration for the social aspects of resilience, as the community plays a large role in the resilience of a system. And furthermore, the inherent nature of a resilience index is such that it usually isn't suitable for long-term predictions. They usually don't make use of modeling or future analyses. And so in light of climate change, a resilience index is not always the best method to quantify the state of a system in light of climate change. This brings us to the objectives of our study. So firstly, on the coastal analysis side, we want to examine the historical morphological data to track erosion and accretion trends, as well as the development of various coastal indicators along the Barrier Island. We then want to integrate all of these forms of information to develop a resilience index, which is specific to the context of Sisal's coastline. On the social research side, we want to understand stakeholder perspectives on development and tourism of Sisal. We also want to evaluate the community resilience in light of these social and environmental stresses. In light of the future projections, we want to analyze and provide an insight into these by making use of a 1D numerical model. And then finally, we have strived to integrate all of these results into an interactive web tool which serves as a dashboard for researchers, policymakers, and community members. This brings us to our research question, which is how can the multifaceted nature of resilience be understood in the context of Sisal's coastline? And we'll answer this in this presentation. So now onto the research methods, and I'll pass the microphone to Auke.
Thank you, Connor. I will briefly introduce the method used for the coastal analysis, as I think it's going to be a long sit, so I'll try to keep it short. The first step is that we computed the shoreline advance and retreat rates, and we defined key coastal indicators. And then the second step is we analyze these condor indicators, after which we combine these indicators into a resilience index. and the computed shoreline advance and retreat rates are used to compute the USGS vulnerability index for Sisal coastline. And the final step is to visualize this coastal performance on the interactive map that Connor just discussed. So the shoreline advance and retreat rates are obtained using the historical profile data that Connor just mentioned, obtained by the researchers of UNAM here, Gabriella and Gemma. But we've also done a satellite image analysis using COSAT. As you can see, west side of Sisal. We also decided to keep them separately and define indicators for each side. So the west side, we defined the scarp toe elevation, the mean elevation, and the beach width. And for the east side, we defined the max dune elevation as a key indicator, the mean elevation and the beach width as well. But the beach width and the mean elevation are defined differently. On the west side, and on the east side, it is considered over the whole project. Then the resilience. We defined resilience as the ability to prepare, plus the ability to recover, plus the ability to resist. And these three aspects are captured. The ability to prepare is captured mean value of an indicator. The ability to recover is captured in its rate, its linear rate, and the ability to resist is natural variability that occurs. And then we compute this for the three indicators that were just listed. And with a weighted average, we computed a single resilience index. That's not the only thing we've done. Like Connor just said, we also make future predictions using a 1D model because these linear trends are not the best prediction for future scenarios. And we analyze the coastal response to extreme storm events as they have a high impact on this coastal system.
Well, I will also briefly explain the method for the 1D model. So this is a typical flowchart that normally you use for modeling. First, the inputs. So we have the data from offshore wave that we have here in Sisal. And then with this, we can build an SFI curve. Basically, what it says is relates the orientation of the beach line or the relative angle between waves and the beach with the sediment transfer rate. This is yearly average. So this doesn't show behavior for peaks or for storms. Then this is the input for the parametric model. We use a explicit method to kind of discretize the grid through the shoreline. And then we look for convergence and stability, trying to find a specific grid that leaves us suitable angles to have a rate, continuous rate. And then you add bypassing and then a shadow zone effect, bypassing from one side of the breakwater. So we know that when the peak is reached here, we have bypassing through the other side. And then shadow zone is just the effect of how the breakwater covers wave energy. And then you have less transport in the other side. Here you can see also an example of how we calibrate it. We have the blue line, that is the model, and then the orange line or the brown line, that is a clear shoreline. It's a quite good fit in terms of how much accretion happens in breakwater. It's quite a good fit in the length of effect. And in also quite a good fit. The only difference is in the pier, but mainly because also the pier probably traps more sediment, and we found that in the model. And then with that, we can run two scenarios that we will explain later.
insights on storm impact.
Right, thank you, Jim. And then finally, I'll get into the methods that we use for the social research, as the technical side is of course important, but effective coastal management strategies are also very important in the sense that it's very influenced by the policies and the strategies that is used by the community itself. For the social research, we first did a stakeholder identification with most of the people here at UNAM, but also with the community itself. And afterwards, we did a lot of semi-structured interviews. For this, we first did a participant selection to get a broad selection of different backgrounds that are related to Sisal's coastal system. And after these semi-structured interviews, we did an analysis of the social dynamics that are related to both the community of Sisal and the developments that are currently planned, but also on the coastal system changes that we've seen. This analysis of the social dynamics is then reaffirmed by a few other methods to see if these findings that we see from the interviews are correct. We did a stakeholder classification process in that sense, a social network analysis, the priority list study, and the stakeholder perspectives. This is all done with information from the interviews, but also with a thorough literature review. Then onto the results, and I'll give it back to Auke.
Okay, so first I will want to present the results of the erosion accretion rates. In red, you see the rates obtained with the profile data. And this is not specifically new. I think a lot of the researchers here already know this. This represents the west side. You need to imagine the port here. And then you can see that west side of the port, because of the sediment flux that goes from east to west, you have strong accretion rates reaching up to around like 4 to 6 meters per year. On the east side, we see the effect of the accretion. So now the port is located here. I think I can go to this side because I think this screen is large enough. Oh my God. So you can clearly see the erosion patterns. And so the red values are obtained using profile data, but the blue values is the extended domain using COSTAT. And what you can see is that actually the satellite image analysis is able to have like quite a good fit on this erosion accretion rates, as for west as for east. But you can extend the domain. And then what is interesting to see is that you have this strong accretion, but you also have other fluctuations in erosion accretion rate if you consider the same time used for the profile data. So this again is like the overview. It's in the center, the erosion rates on the left and the accretion rates on the right. These fluctuations are probably a result of the coastline's curvature. Then the result of the USGS index.
So this requires a little bit of context. We computed a number of indices and analyzed lots of indicators. So it didn't all fit in the method, but the USGS Coastal Vulnerability Index is an index which assesses the vulnerability of the coast. And it makes use of a number of morphological and hydraulic parameters. What's important to note about this index is that there is only one parameter which really varies over the spatial domain of Sisal, and that is the movement of the shoreline, so the relative advance or retreat of the shoreline. The other parameters that the USGS index includes are things such as the geomorphology of the beach, which for all of Sisal can be considered a barrier island. As well, it also considers things such as the tidal range or the sea level rise, and these have all been extracted from Era 5 measurements and from literature, and they have all been considered to be constant for this spatial domain. So naturally then what you see when computing such a vulnerability index is that it is highly dominated by the fluctuations in the shoreline advance and retreat. And so on the west side, you see that it has a relatively high vulnerability because of this erosion which is happening, whereas on the east side, the vulnerability is scoring lower due to these accreting rates. However, a big weakness of an index such as the Coastal Vulnerability Index is that it doesn't really capture the intricacies of this system at a local level, and it doesn't really highlight influences from, for example, human perturbations such as palapas or the port. And it also fails to capture the nature of the system, so the West Scarp system or the East Dune system. It's probably better for a larger scale analysis. And so moving to the Sisal Resilience Index, we constructed this using the coastal indicators. There are a lot of figures here on the right. Basically, what we have done is that we've assessed all of them per indicator. So looking at the maximum dune elevation, the mean elevation, and the beach width. But we've also assessed them per component of the time signal. So we've looked at the mean state, the linear trend, and the variability, which was found by taking the detrended standard deviation. And what is interesting about these figures here is that it really highlights particular profiles along the east side and what their exact weakness is. So if you go here to, for example, P20, which is by the port, this figure in the middle here is presenting the variability. And so because of the breakwater and the bypassing that happens, the all of the indicators, dune height, mean elevation, and beach width, exhibit a high variability, which has a negative influence on its resilience. Meanwhile, if you were to look at the 9th transect, which is the transect in front of our house where we've been staying, and right there, the dune has been completely removed, including all of the vegetation. And so you can see that the mean state is really, really low for all of the indicators. And so it's nice to see how these different components can affect the resilience. We then summed all of the components to eventually come to a single index, and that's presented here on the right. And from this, you can see that P20, P9, P4, and P1 are the least resilient. So that's here and here. And this is where our house was with the removed dune. And all of these indicators with a low resilience correspond to an anthropogenic perturbation. So the placement of the breakwater, which is causing a high variability, the removal of the dune, which is reducing the mean state, or the presence of the pier. And in the other side, the most resilient indices, so P14, P8, and 5, are coming across well with the most resilient transects from previous studies and the other indices that we presented beforehand. So it seems as if the Sisal Resilience Index is capturing these effects quite well. This is then the context with so this is P20 with the port, P9 where you see that the dune has been removed, and then P1 here where the pier is present. And now onto the 1D model results.
Thanks. We wanted to see what will happen in a time horizon similar to the calibration time. So we went to 25 years from now, starting from a current shoreline status. And we changed the length of the breakwater as the main variable for the scenarios. In this case, we have a time the breakwater we have now, 300 meters. And you can see, well, it's clear that this is the accretion side, this is the erosion side. I think it was interesting to see what happened, for example, in the accretion side in the pier. Well, you have a fully accreted tip of the breakwater, so that saturation in there kind of limits the wave of sediments that is going to be trapped. And you have a pier that is at 40 meters around. Also, the sediment wave goes until 3 kilometers of effect. So in the the perturbation starts at 2 kilometers, but in 25 years, he says that it will go further than that. There's a limitation with that because the pier probably will trap, and so you will have also erosion here, kind of what you see from the current state. The model doesn't capture that, but for the calibration, it's quite okay. And then in the erosion side, you have clearly a shadow zone effect, less than 500 meters from breakwater, and you have trend of 6 meters per year in erosion. Also, the erosion wave extends 3 kilometers from the breakwater, and that's also interesting to observe that it will be a smaller effect than the accretion side. This fits kind of the trends that we see from past years that we see with the only difference is that here there's still erosion in the breakwater, but it's captured now that it is accretion, but for now it's quite a good fit. And now what will happen if the breakwater is double the length? Clearly, the tip is not saturated anymore, so we will have a bigger wave of sediment coming, and the pier will have more accretion. Clearly, we have around 55 meters of accretion in the pier. That's 15 more meters. I think that will be a big effect also for people living west from the pier, and then the wave of sediment will trap around 250 meters more. And in the erosion side, what will happen is that the shadow zone will be swifted to the east, to the west, sorry. So we'll have more erosion in this side, and the sediment wave also will be around 3.5 kilometers. So that's also more effect of erosion in this side. In terms of how fast the erosion will happen, I see that the trend is similar. I think this is because of the factor of the bypassing, that is not exactly the number, but how fast it changes. So the effect will be more around this peak and not around this area. But there's something that we should observe, because also the bypassing takes into account the surf zone, and then the surf zone, it's relatively close to the shoreline. So I don't know if the making a bypassing factor relative to the breakwater is the best fit, but yeah, this is the results for also double length of breakwater. Here you can see a comparison between two places that we observe, the breakwater and the pier. And you have clearly in the scenario A a smaller rate because the tip is fully accreted. Then in scenario B there's more space for accretion, and then in the pier is more stable, let's say, with 2 meters per year. That also fits what we'll observe in the last 5 years of satellite image. And then for the erosion, we have a trend as well here of 5 meters per year in the peak of erosion. And in the breakwater, we have higher accretion in scenario A. Also something interesting to observe is that you can quantify how much area you lose per 5 years. If you subtract areas of erosion, it's around, yeah, maybe it's just to conclude, you can see how much area you lose per 5 years of erosion, just subtracting areas. It's around 40,000 meters, square meters, and this kind of seems constant through the time. And it's because the erosion rates are also, well, it's not exact line, but you can see that it trends in, at least in the first 10 to 15 years, a linear trend. And then because it's a fusion equation of sediment transport, then you have a non-linear decrease through the time. But for, I think, this scenario, 20 to 25 years is quite good behavior in terms of how a linear trend will work. And now I think, yeah.
David, back at the storms. So you wanted to get insights on how the storms affected the coast. We looked at in total 4 storms, which we had data on for both east and west sides. So we computed the indicator response, and it appears to be quite random, and also highly storm specific. And for example, different storms showed different responses, so positive or negative. And also it seemed to be highly variable among the transects, with consecutive transects showing opposite results. For example, at one transect, the waterline would go land inwards, and the transect next to it would go sea inward, land outward. So it was quite interesting. So we looked at a total of 5 indicators, but the subaerial volume change was the only indicator with a clear pattern. The subaerial volume change is basically how much volume of beach or dune is changed. And in this graph, you can see the total amount of subaerial volume change over all the storms we we looked at. So you can see here is the port, and left and right to the port there is subaerial volume loss, but in most of the other transects there is actually gain. So I think based on subaerial volume change, you can say that the coast is strengthened apart from the transects near the port.
Yes, thank you. And then onto the social research. The results of that, I'm going to stand in this part because I've got a lot of figures that I want to show you and highlight. And here in the background, a nice picture of one of the interviews that we did at one of the palapas here at the beach. Onto the results of the social research, specifically on the stakeholder identification process. In total, with the help of you and a lot of other people here in the community, we eventually identified 48 individuals and organizations that were potentially interesting for our social research. Of these, eventually 23 were identified to potentially select as an interview participant. And apart from that, we've identified 13 stakeholder groups that are related to the coastal system of Sisal. And you'll see those in a lot of the results as well. Eventually, of these 23 identified stakeholders, we managed to do 16 full-length interviews, which were of a semi-structured pattern or manner, all being around an hour, some of them being a bit more, some of them being a bit less. During these interviews, we talked about the participants' connection to Sisal, their knowledge on the coastal developments in recent years, but also on the economic development of Sisal. Then the communicative relationships that they've had with other identified stakeholders in the coastal system. And finally, on the priorities and perspectives on the Sisal's future. Here you can see a categorization of the backgrounds and the connection to Sisal's community of these. You can see that they add up to more than 16. That's also because we did 5 short interviews to gather more results on the perspectives. Eventually, we spoke to 6 people of the local businesses, 8 researchers, 3 government representatives, and 4 inhabitants. And as you can see, these are categorized in about half being outside of Sisal's community, not residing here in that sense, and 10 of them being inside Sisal's community. Then we gathered all the results from the interviews and had 6 main social dynamic takeaways. These are that, first of all, there's a big difference between economic development and nature preservation, as we have seen. In recent years, a lot of community members see that they really value the economic development of Sisal, specifically by increasing the quality of life and increasing the infrastructure services that Sisal has to offer. But in recent years, you can see that this has a price, as nature preservation initiatives have noted that there's a lot of loss of ecological zones, specifically because of developments around the beaches, like in the natural reserves. Then a changing climate is already mentioned by the guys from the previous presentation, is that fish migration patterns are changing due to a warmer temperature in the ocean, and therefore increasing the pressure on the fishing industry of Sisal. Therefore, you can see that there's a bit of a shift in the economic sector, where also because of the increased tourism activities, that the tourism industry has a higher share or increasing share in the economic sector of Sisal. Therefore, there's a lot of pressure on a lot of inhabitants of Sisal that are related to this fishing industry. Then Sisal can be seen as a bit of a difficult political landscape in the sense that they're connected to the municipality of Hunukma, who also have a lot of priorities to deal with, which might not be the economic development or the coastal management of Sisal. In that you can see that a lot of inhabitants mention that they don't have a lot of relationship with the government and only really reach out when they have to, whereas the government has a very passive role in the sense that they don't reach out a lot and aren't very transparent on the decisions that they make. I'll get into that later as well. Then UNAM is, of course, a bit of a knowledge island here. That's not necessarily geographically, but also because of the connections with the community in itself. UNAM has done a lot of work to be able to collaborate with the community, but a lot of community members themselves say that they don't really have a lot of contact, but also because it's difficult to reach community members, also because of maybe a bit of a frictionless history when the establishment of UNAM became to be in the start of this century. That doesn't mean that UNAM tries, because UNAM does a lot, but it's difficult also because of the highly technical nature of the research that UNAM does. Then going back to this political landscape, Magic Town destination, the nomination of the Pueblo Mexico in 2020 has caused a lot of increase in tourism activity here in Sisal. The community has a bit of a mixed feeling about this nomination, with most people actually having a very negative view about it. They don't really value the tourism activity that it has caused, because it also caused a lot of infrastructural pressure by outside real estate developers. In that sense, it's also a bit weird that a lot of community members have never really heard about the Magic Town nomination before it came to be, because the decision to become a Magic Town wasn't communicated at all to a lot of community members. And therefore, they feel that they were left out of the decision-making processes, which has caused a lot of self-organization within the community, also leading to other effects, like illegal construction on the beaches in the Palapas, for example. Then on the future development of Sisal, we've asked a lot of interviewees about what they think of that. And most mentioned that they think the expansion of Sisal is inevitable. A lot of new developments will take place in coming years, but it doesn't necessarily mean that it has to be something bad. However, in the current nature and the policy that is enacted, a lot aren't very, don't think very positively about the future, but that can still change, of course. Then we gathered these results and then did a lot of reaffirming with other methods to check if these results were valuable and to check them, basically. What we did is a stakeholder classification process where we identified 13 stakeholder groups, as mentioned before, which you can all see here on the power and interest grid slide. With this, these stakeholder groups, we categorize them in specific key system roles, which are relevant for a complex system like the coastal system and the coastal management of Sisal, and see what type of roles each stakeholder has. When you then compare them to each other in their level of power and their level of interest, you can clearly divide and see which stakeholder has which role within the system. If you look towards this power and interest grid, you can clearly see that there isn't a stakeholder that has very high interest and high power within the system, which is something that is, can be a bit of an issue. Apart from that, the key system roles are categorized around the same place, where you can see, for example, that the advocates are all around the same area, meaning that the outcomes of the interviews are reaffirmed by the power and interest grid. Then a very important part is that there is a lack of a guardian role within the system. A guardian means that there is a stakeholder that checks or evaluates the imposed regulations and laws by regulators so that the system works as it should. This is very important because this absence of a guardian can cause other management issues. And that is something that you don't want to happen, of course. There are definitely stakeholders that are trying to be this guardian, but sometimes lack the authority to be able to change the system themselves. This then reaffirms the social dynamics that I've talked about before. Then we looked at the communication network of Sisal's coastal system. During interviews, we asked every stakeholder about their communicative relationships with other stakeholders, and then asked them about how frequent this relationship was, if they deemed this an effective relationship, and as well as what type of relationship it was. Was it them sending information, them receiving information, or was it a bit of both? As you can see, there's quite a strong hospitality sector in Sisal, especially because of the increased tourism sector, a lot of collaboration with the hospitality sector in the firm, in terms of the palapa owners, the restaurant owners, the fishing industry, as well as the tourism industry. Here you can also see a bit of a passive governmental institutes that I've already talked about, as they've got mostly a receiving relationship with a lot of stakeholders, meaning that a lot of stakeholders reach out to them, but they don't really do that much the other way around. Then you can also see the position as UNAM is a bit outside of the centrality of the network, with UNAM trying a lot to show and communicate their findings of their research to other stakeholder organizations, but not really having a lot of communication the other way around. And then real estate developers located here have quite an interesting position in this communication network, because they're one of the only ones that have both a receiving and sending relationship and a direct connection to the municipality and the tourism sector. And then finally, the mental maps. Some of you might recognize the mental map that you've made. What we did is, for the stakeholder perspectives part at the ending of the presentation of the interview, we asked someone to draw Sisal in 2070. We gave them a blank piece of paper and asked them, how do you feel Sisal will look like in 50 years? And in that sense, it wasn't about what they wanted it to be, but what they actually realistically thought it would be. In that sense, we compared how these different mental maps looked and analyzed the characteristics of them. As you can see, maybe from the mental maps itself, it was quite difficult for people to imagine something on how Sisal will look like. This is also because there's a pretty high amount of uncertainty involved in Sisal's development in the coming years. It's quite difficult to imagine what Sisal will be in 20, maybe 30 years, and therefore 50 years is even more, making it quite difficult to imagine that. Then we saw that experts with a technical background drew a lot from their technical, from a technical theme, related or being more focused on the climate or maybe the coastal system, whereas the inhabitants were more focused on community cohesion. In that sense, we can also see that there were a lot of recurring important cultural landmarks. For example, community members drawing the church or the yellow entrance gate. So now you also see what that means. As well as that we looked at the different threats and opportunities that a lot of these stakeholders note, with the main opportunities being increased accessibility of Sisal, tourism being able to provide more economic opportunities, as well as housing development and infrastructure development. However, there were also a lot of threats related to this, like gentrification, inequality, segregation, or the loss of ecological zones, which is of course something to take note of. Then on to the web tool.
Thanks, Jim. Okay, Jip. Sorry. I will briefly show you the web tool that we have developed, because it was one of the main deliverables of the project, with the aim to clearly visualize our results in a very simple way and also an interactive way. So researchers or other third parties can click what to visualize, which transect they want to show data of, and all that kind of stuff. So when you enter the web tool, this first you see a home page with on the left some information displayed. You are able to download our report. And on the right side, you see an overview of all the tool functions that are present. Then the first thing, you can visualize the erosion accretion rates on a map. And this in one overview gives a very, I think, good representation of what happens or what has been seen in the last year. So you see the strong erosion rates on the west side and the accretion rates on the east side. You can click extend the data using the satellite images. So here you see that the domain is extended. You can click on one of the profiles to see to clearly visualize the actual trend. And for example, here, what would be interesting to investigate for researcher, for example, is it looks like the trend is deaccelerating in the more recent years. So you can select a time window and select, for example, I want to see only the data represented from 2020, and then you get a new result, and you indeed see that the accretion rates here is less than when you consider the whole data frame. And this is possible for all the indicators, all the erosion accretion rates, but also for the indices that we have computed. On the left menu, we now show the extended index using coastal satellite image, and this represents the result of the USGS index. So again, clearly the distinction between east and west, where west is characterized by the strong erosion rates, and east has performs better with having a lower vulnerability. Then the Sisal resilience index, this is the one we computed ourselves, specifically for the east side. Again, you can see the performance in one overview. So you see that profile 9 has a relatively poor performance. Also, the sections next to the pier and to the breakwater at the west side perform badly. On the next page, it's possible to visualize all different indicators. On the left, you can select your indication. Indicator, and here the Scarpto location, the trend of the Scarpto location is visualized. And as with the erosion rate, you can see the retreat of the Scarpto land inwards. You can also choose to again visualize the trend. Then this is an example of the current state of an indicator where the max dune elevation on the east side is presented. And here also in one overview, you clearly see that the profile 9, the dune, has been removed partly. Again, you can select the time window, which only makes sense for the trends. And if you show the current state, you can click on the profile and it shows the selected indicator on the cross-shore profile. Then we also visualized a map with all the relevant stakeholders, but not only the stakeholders, also critical infrastructure and coastal infrastructure. So the breakwater is highlighted, but also submerged breakwaters that have been implemented. You can see the different development areas in the natural reserves. And on the final page, you have a summary of the quantifiable data that has been obtained with the social research. Discussion and conclusion, that's my part as well. The strong point of our method, I think we made a very comprehensive study resulting in numerous insight in different aspects. So we have done a lot of different side studies and tried to combine all these to one. And I think it gives like, it is a very broad spectrum. We have a clear visualization of the coastal performance through these indicators. We have developed a reusable algorithm for defining these indicators, which can be optimized by the researcher itself. So it's easy to calibrate them again or define them a bit differently. And we try to make the Web2 very robust, so it's updatable. For example, within a few weeks, Gemma and Gabby will have more data available and they can easily implement it, and all the trades, all the trends, everything will automatically be recalculated. The weak points is that our whole research, as a lot of researches, are based on a lot of assumptions and error. For example, the algorithm that defines the scarp toe has quite a relatively large error. Also, we only have interviewed 16 people, which might not be a very good representative for a whole community. The linear trend that we have used often is not a very good approximation for the data. You could try to make a better fit, but the strong part of a linear trend is that it's very easy to communicate to third parties. The All Resilient Index only considers a limited set of technical parameters, and this is actually always the case when you use an index. It is a clear visualization, but you lose a lot of detail in your analysis. Then our strong point is also part of our, is kind of like a weak part as well. So we have done a lot of things, is a strong point, but we have done a lot of things can also be a bad part, because it might be difficult to combine everything in one comprehensive research. Then the answer to the research question.
Yeah, so that brings us finally to the conclusion, and then we'll bring the research question back. So that's, how can the multifaceted nature of resilience be understood in the context of Sisal's coastline? And I hope that what we have said so far answers that question. And so to conclude, we've split the conclusion into two parts. Regarding the performance of Sisal's coastline. And so in a coastal sense, we see that human interventions have a highly local and a highly negative effect on the coastal resilience, which is shown by the Sisal Resilience Index and is confirmed in previous studies. Then generally takeaways from the east and west domain. So for the east side, we can consider it generally quite resilient in the context of all of Sisal. It exhibits growth in many indicators, such as the growing shoreline position, as well as the growing dune heights. However, transects near infrastructures show a very high variability, which reduces their resilience significantly. This also accounts for things such as palapas. For the west side, sadly, we haven't been able to compute the Sisal Resilience Index for the west side. We'll get to that later. But from our analysis of the indicators themselves, we see that it's obviously characterized by lee side erosion and a significantly retreating scarp toe. And what we see on the west side is that actually the beach width stays the same as the scarp toe retreats at the same rate as the shoreline is retreating. And so there's a lot of recommendations on the west side, I think, for future research, because it can be a little counterintuitive when looking at a specific indicator. And also linking this to the social side, the significant erosion on the west side conflicts highly with the current real estate development that is happening there. Lots of beach homeowners are significantly worried about the future of their property because the west side is eroding so quickly. Then in the social side, we see that the coastal management, the current coastal management strategies are not effective enough. And we also see that from speaking to the community of resilience appears low due to the pressure of the infrastructure that is placed upon them. They're not taken into the these conversations regarding the development of Sisal, and then all of a sudden a magic town status falls upon them, or a unauthorized 5-story building is constructed on the barrier island. And this significantly threatens the resilience of the community, as Jip said, leads to self-organization, and then also the derailing of certain future strategies. And I think the figure here on the right illustrates where Sisal sadly might be at the moment, and we identify that there is uncontrolled coastal development, there is often inadequate coastal planning, and there are also inappropriate coastal structures, and that really does put the system in this bottom left corner, which nicely ties in the effects of the socio-economic system to the natural system. And so I think, to conclude, it would be nice to eventually come up with strategies to move and reposition the development of Sisal to take into account things such as building with nature strategies, better nature conservation, or coastal protection. Sadly, this is easier said than done, and our study has mainly focused on highlighting the information that is available, and strategies are highly needed to improve this. Then the recommendations.
Yes, and then finally the recommendations to conclude everything. So we divided them again into the social recommendations and some technical recommendations, as well as some future research points that I'll get into later. Firstly, about the social recommendations, improving community resilience is going to be very important. An area or a coastal area or an urban area is only as resilient as its community. Therefore, to UNAM, it could be interesting to explore the possibilities to advocate for policy changes. Of course, it's not UNAM's responsibility to do so, but if there are opportunities or the willingness to do that, it could lead to potential positive effects. A means to do that, for example, is through white papers where experts notify policymakers on specific expertise regarding coastal management or coastal policy strategies, and therefore maybe be able to give them the information that they need to get better and more effective strategies. Furthermore, it's important to keep building this awareness on the community. That's already been done with a lot of these workshops or citizen science approaches like the CoastSnap pier that's on the pier. But it's of course important to keep building this awareness and strengthen these community relationships, as together it's makes a strong point for reaching better situations, I feel like. Then onto the technical recommendations. It's important, as Connor already said, to recognize there's a difference between the east and the west systems, east of the port and west of the port. And it's important to be aware that there are limitations when you are comparing both the systems if they've got different indicator values. Then the human perturbations that are present on the coast are best captured through the coastal profile indicators, as these tell more about the local system than other indicators that are more mean. And finally, the technical resilience index that we've made should of course not be the sole basis of policy changes, as I've already mentioned that the coastal management strategies are also highly related to the community and the social part. Then onto the further research. It is then important to maybe see if there's an ability, the possibility to construct a resilience index for this west domain, as we've only done it for the east. And in that, maybe to include the vegetation data or the drone flight data that UNAM has already gotten. Then it can be interesting to extend the domain past the 2 kilometers on the east and the 2 kilometers on the west that we've looked at by the coast satellite methods, for example, or more transects in other parts of Yucatan. Then for the 1D model, it's interesting to add a dynamic shadow zone. And apart from that, quantify the bypassing from the west side, or the east side to the west side, and also include a surf zone. And finally, for the social research, it is important to more thoroughly understand and research the decisions about maybe the Magic Town status, but also on future developments, as a lot of people in the community now don't really know why certain decisions were made. Apart from that, it's of course interesting to conduct studies with more participants, as these will reduce the amount of errors and assumptions that you have in your research. Thank you so much for your attention, and we're very interested in all your questions and feedback. Questions?
Well, thank you. Congratulations.
We can hear.
Congratulations for your work. You have a very good perspective of Sisal, better than many people has here. The town? Hello? Test? 1, 2, 3. Okay. I wanted to ask you about the interviews with the people. There's a formal technique to plan and make an interview.
Yes.
How did you acquire that technique, or where did you get it from in order to apply it to Sisal?
Yeah. There's a lot of literature about conducting interviews, and of course, there's various ways in the ability to conduct them as well. You can do it structured in a sense that you just make a lot of questions and you just solely ask those questions, or in an unstructured way when it's just a free-flowing conversation. We did a bit of both, as a semi-structured interview gives you some flexibility to talk about other interesting points that stakeholders might mention, while still capturing the data that you need to be able to compare different results to each other. We did that, of course, with a lot of researchers here to be able to understand what are interesting points to ask. We had a meeting with Gemma and Gabriela about all the stakeholders that could be interesting, and then other researchers here and the various talks that we've had has provided us with a lot of valuable insight, which led to a template for these interviews. And we asked that template, basically. I think it was 9 questions in total.
Thank you. Congratulations.
Thank you.
Thank you. Very nice. Congratulations. Also, there are many different aspects that can be studied for resilience, right? There is the beach resilience, the social resilience. What others you think should be analyzed? The social includes economic, includes and health and pandemia, and what other aspects?
Yeah, social resilience should, in theory, incorporate all the different aspects that are related to an urbanized area, in the sense that economy, health is of course also very important. For us, it was very difficult to be able to research all the different aspects of resilience, of course, because it's such a broad term. I think Connor as well mentioned that there's so many different definitions of resilience, both in the technical side, but also in the social side. And in that sense, I think we tried to incorporate most of the social side, but also make some boundaries in the sense that it's still related to the coastal system. Of course, I think further research would be very interesting in incorporating more parts of resilience, but that is of course difficult in a short time span of 10 weeks. So,
yeah, of course, yeah.
Yeah, I think it's a really good question. Resilience is a super ambiguous term, and I think every field of research has its own definition regarding it, whether it's psychological, social, health, and the coasts. I think one of the objectives of our study as well was to present this ambiguity in an online tool, and to give people not per se one index that is all saying, this is the state of Sisal, but to give many different perspectives. So we really struggled through our research actually in how can we combine technical values or parameters describing resilience with social findings. And is it even something that you want to do? Do you want to try and stick a number on someone's perspective and then integrate that into a single index? Eventually, we decided that that was not ideal, as you often have inherent biases, and you don't, as outsiders as well, I think it would be wrong for us to do that quantification. So I think we have primarily focused on quantifying the coastal system and to give an index that is accurate on that side, but to present it next to the social findings, such as the mental maps, the whole research on that side, so that you can view them side by side in the web tool and realize that the resilience is not always pointing in the same direction. I think that was the end goal. Yeah.
That's great. Thank you. Very nice.
Thanks a lot. I was wondering, after Hurricane Milton, we experienced quite a big rise in the level on the beach. Do you think that improved or decreased the vulnerability of Sisal?
Well, it is interesting indeed, because what we see, if I can compare it to the Netherlands, is often that storms have a negative impact on the vulnerability of resilience. And actually, indeed, from our research that we have performed, you often see that an elevation gain or a lot of accretion after a storm. So yeah, storms do seem to have sometimes more like a recovery impact than a negative impact. And for Milton, I think we have discussed this as well with the researchers here, but it kind of has reset the whole beach profile. So like these storms do have like a very high impact, and the system is really sensitive to these variabilities.
And I think related to that, on the technical side, it could improve resilience, but of course on the social side, it doesn't. I think all of you have also noticed that, for example, on the infrastructure side, Milton has caused a lot of difficulties for Sisal as well. So sometimes in the technical side, it can improve it, while on the social side, it being a negative consequence, and therefore also seeing how this can be a duality in that sense.
Sorry. I think it's also highly dependent on the east and the west side, how it reacts. So the storm impacts is really different when considering both sides. So I think really one of the things we've learned as well from this study is that resilience is so highly dependent on the local, like the location and the specific system, and that it's really hard to generalize resilience. And even in this small, domain that we've considered, you see drastic differences. And so on the east side, storms have caused, the beach to gain enormous amounts of sediment. And you can see it by looking at the palapas, and that they now come up to like your hip sometimes instead of when they were above your head. But on the west side, you see that the storms have drastically caused the scarp-toe to retreat, but also the beach to gain sediment. So it's like, it's quite complicated, I think. So storm analysis is definitely something that requires more attention. Yeah.
Thank you.
Well, congratulations and special thanks for combining all this information in this great web tool. And well, my question has been stolen. But yeah, actually, I wanted to ask you about these volume changes that you found with the hurricanes, with the 4 hurricanes. Because yeah, what we have seen before is that, as you mentioned, that we gain a lot of sediment on the east, but sometimes we have a negative effect on the west, but you find volume gain throughout both sections, right?
Yeah, so over the 4 hurricanes we analyzed, there was indeed, like summed up, there was a total volume gain, yes.
Yeah, so it was really interesting because, as you mentioned, like even in the east side, when you don't have like or you're not very prepared for the storms, you can have a negative effect. But even though the west side is, I mean, with this scarp profile, you find all this sediment gain. Did you compute it from the 0 elevation above, or?
Yes, from 0, yes, from sea level.
Okay. Yeah, that's really interesting. But Milton is not included here.
Yes,
right?
Milton is also included.
Okay, okay. And do you have an idea what's the contribution of each of the storms? Like which one contributed the most to this?
Oh, I can say for sure that Milton was like the best for the beach system, yes.
And do you remember if you had sediment gain for the 4 storms, or just the net, or you just had a net increase combining all the storms?
Yeah, this indicates the combined storms. So out of the 4, some were like negatively affecting the coast, but in total they were, well, it was like this, so it was positive.
Yeah, so that's that was actually our like in terms of the resilience, that you have like an increase of resilience, or you may have an increase of resilience from storms, but we are not considering the social part, no, in our studies. So that's and it's like a whole new thing for me to think on how to combine that.
And in that sense, it's of course also very interesting, as we've shown in these storm analyses, that the frequency of storms is increasing, and therefore potentially the effects that it will cause on Sisal is also increasing. And therefore it's quite interesting to see that Sisal is having all these development plans and building all these big buildings, or planning on doing that, even though there's a big chance that there will be damages to this. In that sense, you can ask yourself why you would develop that. Which is of course also an interesting social part, I think.
Yeah, like we think, great, we have much more sand, no, on the on the emerged beach, but now the palapas are useless, no.
Yes,
so
exactly.
Someone wins.
Thank you, guys. Very interesting. It's interesting to see how you can put into a scientific questions or presentations the difficulty of combining social aspects with natural aspects, right? And how both can be opposites in situations, no? Maybe it's not a question, it might be just a comment, because I think it wasn't part of what you did, but certainly regarding these storms, like hurricanes, the other part that I've seen that affects a lot, in particular here in Sisal, is all the water coming out, the groundwater level getting out, and the flooded that it caused in any part that it's now being developed, right? So it's like, of course, it's not part of what you did, but it's something that maybe in some other work can also be taken in count on the social part and maybe on the natural part too.
Yeah, it's not mentioned in the presentation in itself because we're more focused on the coastal side, indeed. But we have also had interviews with researchers that are more focused on the groundwater side of Sisal. And they also mentioned that there is a big threat of more salination, but also a lot of unregulated discharge because of these new developments, potential climate change effects that are also causing these negative effects to the groundwater, not only because of the storms, but also a lot of other social and human intervention sites that are currently threatening this groundwater, and that will probably or maybe become a very big threat in the future. As water supply is already difficult as of now, and this pressure on this groundwater will probably increase it. Yes, so that's a very important part as well.
Thank you.
Hey, can I ask a question?
Of course, Jaime.
Okay,
Perfect.
go ahead.
Sorry, it's just that I don't have a hand there to say, hey, I want to ask.
You're on the screen now.
Perfect, thanks. So first of all, congratulations. I'm very happy to see all the work you have done and you have managed to achieve, even though you are at the beach enjoying life. Congratulations for that. I was a bit curious about the Sisal Resilience Index, because you mentioned that the USGS index was basically not suitable for Sisal, and that it might be better suitable for larger extensions of land, for the larger scales. But then the part of Sisal, that index requires a lot of data. Or could you manage to get a similar index just using remote sensing data?
Well, yeah, the problem with the USGS index uses, I think, 5 parameters, and the only one varying in this coastal stretch is the erosion accretion rates. So once you have data about the sea level rise, about the morphodynamic, geomorphodynamic system, wait, I can go to the extra slide. But then with accretion and erosion, you can compute this index for a larger domain. So also the slide I presented in the web tool is the USGS index constructed with the COSAT satellite images. So yes, it is possible, and that's why we still implemented this tool, because the domain of Sisal is a bit too small, maybe the 2 kilometers to the west and the 2 kilometers to the east. But if you would extend it using the satellite images, and you would have information available about the geomorphology, the coastal slope, the relative sea level change, mean tidal range, and the mean wave height, you could extend this domain, and then you could also compare it to other coastlines where this index has also been used. So that's the power of this vulnerability index.
Okay.
And
And
apply the. Oh, sorry, Fiverr. Could I add one thing?
yeah, please.
Yeah. I think this is a really good answer from Auke in terms of applying the USGS index in a larger domain, but then indeed the Sisal resilience index is relatively data intensive, and it requires quite a high density of data along the domain to quantify it. I think it is its strength, also its weakness. What could perhaps be a possibility is to use drone measurements, which are also taken here in Sisal, to, for example, identify the maximum elevation of the profiles. I think this could be possible with certain algorithms. And that could be a way to extend and simplify the gathering of that data, although I'm not sure what effect that has in terms of its accuracy. I think for things such as on the west side is particularly difficult due to its scarp system, and I think, it would be very hard to capture with a drone measurement. I think it would maybe have more potential on extending the east side. I think this is an interesting question to investigate more and to see how it could be applied in a larger domain, because extending the number of transect campaigns, I think I can see Java laughing, like the amount of effort that goes into them. I think we went on one of them and they go every 2 weeks and we were absolutely destroyed. So I think extending the transect campaigns is definitely easier said than done. So I think it's an interesting question.
Yeah, perhaps you could do some citizenship science using that, no? Like developing a system on how to upload measured profiles by citizens to your web tool. That would be
it could be interesting. Yeah, I think it's definitely a big ask for people, because it does still require, like, at least in the context of the transects that are walked now, it's with a GPS and you're walking. I mean, okay, we only use the sub aerial, but they also, cover all of the sandbanks and go up until their chin. But perhaps in the context of the real estate development and people who are very, very protective of their own property and want to know more about, the state, you could maybe integrate it in some way that people, walk a transect in front of the house, so gather measurements that way. It could be interesting.
Yeah, but indeed, there are some ways to measure the profiles without using GPS data. I mean, it wouldn't be as accurate, but it would be a way to involve the community as well and to increase the spatial resolution quite a bit. But well, those are just ideas. And the last thing I wanted to ask you was, you experienced a hurricane recently. Well, not you. You went to the city of Merida. How did the resilience index correlate with what happened? So, for example, inundation-wise, did the transects that you mentioned were inundated, or how did it translate to that? Because you did say that these storms can increase the resilience by putting more sediment in the dunes and increasing the height, but that also means that there were inundations in order for that to occur.
Yeah, exactly. That's a very good point, and I think that is something that we would have to do in further analysis and see exactly with this time window that's possible in the web tool to analyze the change of the Sisal resilience index and the coastal indicators around Milton, and highlight that. I think in the scope of our project, we haven't had enough time to really dive deep into its effects, but I think that would be a great recommendation. And also just from pure observation, I know the other group, they remained in Sisal during the hurricane, and we saw pictures of how P9 in front of the houses was completely inundated and completely flooded due to the poor mean state and the poor mean elevation. And that poses a severe risk to the resilience of the system. So indeed, it does grow, but it does also, the flood risk is something that is very significant during these storms.
Yeah, and I think in this for this case also the web tool is very powerful because especially for example within a month or within a few months when we have more data after the hurricane, you can just visualize the trends before and visualize the trend or the whole index after, and you can see the changes on the map for the computed index.
Okay. Thanks a lot, guys, and congratulations once again.
Thank you for joining in on the late afternoon in the Netherlands. Thanks.
Me again, just curiosity. What's next for you? You mentioned future work, recommendations. I know you are very busy. You are in your last year? Okay, good. And you will have the interest or the motivation to pursue some of this future work, or that's it, bye, and move on. It's very, if it's like that, it's like that, and that's it. But I don't know, maybe some people from Spain came for 6 months, stayed for 4 years, got married with a Mexican, and he even has the Mexican nationality.
I think my girlfriend wouldn't like that.
You have a chance.
With all of the researchers who are interested, and we're going to explain exactly how the code of the web tool is structured, how the repository works, how new data can be uploaded, and we also want to look with Gonzalo and see if it's possible to put the tool on the UNAM website or database. We also have some other possibilities that we found that go through Streamlit, which is this Python software that we've used to build the tool. So I think we are still motivated to do that. But we do also have our commitments in Delft. So yeah, we'll hope to balance the two.
Yeah, and just like the other guys, I think I can speak for all of us that we've had a really good time here, and that it's very interesting to be in a local community like this, and especially everyone being so welcome here. I think we have had such a good relationships with all the people that we've spoken to here, and everyone has been so helpful. And I think also regarding the social research that we've done, it's very interesting how Sisal will develop in the coming years, and I think all of us will definitely be interested in how that will eventually take form. So yeah, stay in touch, I guess.
Well, congratulations. And just a quick comment. Do you think that because the resilience index at the end in the general form has the mean state, the rate, and the variability? Do you think you can apply that to any socioeconomic indicator? Because at the end, you need to feed with some time series that index. So
yeah,
so that will be an opportunity to extend the index, or to try to integrate,
yeah,
right?
We have tried that actually during the research. We have done an analysis of the amount of palapas being built, for example, in the last few years, where you can clearly see there's a big increase after this metric ton denomination. Who knows, there is a possibility to maybe integrate the amount of developments or human interventions that you can see on the beach and see how that has influenced the resilience index of specific transects, for example. But of course, there's a very big but, because all of the social research is very qualitative, of course, and not very quantifiable. So that way, it's probably difficult to be able to add other quantifiable data to the resilience. But for example, the amount of human interventions in terms of area or volume could be interesting to add. Yeah, and maybe some on the tourism activity, or I think we talked before about Airbnb reservations or booking.com, where we've also tried to see if we can get some data from that, which was unfortunately not possible, but who knows, other people might succeed. Thanks. Any other questions? No? Then thank you.